right? So this thing is growing. It's growing in a way that its volume is increasing at 20 cubic centimeters per second. Per second? Yeah. And I want to know how fast the edge of that cube is growing at exactly the moment that the edge is 10 centimeters. So I have what I'm given, what I want. I have a picture. This is the general picture, right? If you want to talk about the instant in time that we're talking about, the instant in time picture looks like this. 10, 10, 10, right? That's what it looks like at the exact moment in time we're talking about. So if I have what I'm given and what I want and I have my pictures, what's the next thing I need? An equation, right? You need an equation that connects what together? I'm looking for any equation that exists in the universe, right? Any equation I can think of that connects what two variables together? Volume and x. And hopefully that's a pretty straightforward equation for you all. The volume is x cubed, right? X times x times x. Multiply these three sides together, you get the volume. So once I have an equation, I differentiate this with respect to? What are our derivatives with respect to? Time, right? So I have to differentiate both sides with respect to time. So what is the derivative of volume with respect to time? dv dt, right? dv dt. So now I'm doing, I'll do it here. So now I'm differentiating both sides of the equation with respect to time. Differentiation, right? With respect to time of x cubed. Right, this is just dv dt on the left. On the right-hand side, I have to use the power rule, 3x squared. But then chain rule, take derivative of the x. With respect to time is not 1, it's dx dt. That's my differentiation step. And now you look at this and you say, okay, what do I have? You know, am I missing anything? dv dt, do I know what that is? Yeah, it's 20, right? Do I know what x is at the moment in time we're talking about? Yes, 10, right? And then here, dx dt is what I'm trying to solve for. So everything I see here is great, right? Remember, you cannot replace x with 10 until after you differentiate, right? So now start plugging things in. This is 20 equals 3 times 10 squared times dx dt. So the right-hand side is, this number here is 300. So I would go 20 equals 300 dx dt. And then divide both sides by 300. And that's 2 over 30, which is 1 over 15, is equal to dx dt. Just reducing, right? You could give me a decimal, that's fine. All right? But what I also want are the units. So this is 1/15 watt per watt. So to get that, we go and we look at this fraction here. X, right? dx, the change in x. X is measured how here? Centimeters. And then time on the bottom, time is measured in this problem in seconds. So you got this cube. The volume is increasing at 20 cubic centimeters per second. At exactly the moment the edge of the cube is 10 centimeters, that edge is growing at a rate of 1/15 centimeters per second. 1/15 of a centimeter per second. Yeah? That's about as easy as a related rate problem as you could possibly get. The geometry in there is super simple, right? Is that a stretch? You'll agree? I mean, I can't think of much more geometrically that could be easier than this. Maybe a square. I could do a square, right? A square would just be x, right? X times x. All right, good. Next. Which one? 19, first page. Area under, oh yeah, good. Did y'all have an opportunity to practice some of that substitution homework? Yeah, how did that go? Do you feel better, a little better about it? Practice, right? Definitely practice on those. All right, so what did you say, 19? Okay, number 19. Find the area under f of x equals the natural log of x over x on the interval 1e. Remember, e is just a number, right? It's about 2.718, something like that. All right, so geometrically, what this is saying is we have some function. We're looking between 1 and e. Whatever that function is, we're trying to find that area, right? But that's what the fundamental theorem of calculus says, right? The fundamental theorem of calculus gives us the area underneath the curve between 2 points. So I'm going to turn this problem into an integral. The bottom limit of integration is 1. The top limit of integration is e. The function that I'm trying to find the antiderivative of is natural log of x, and then we always put dx right there to keep track of our variable. So does that notation make sense to everybody from the question? That means this? Yes?
Does it matter to put the e on the bottom?
It does matter. It's always, you have to know which number is bigger and what's smaller, right? So 1 is smaller than e because e is about 2.7. So when you do this, the number on the left appears on the bottom, and the number on the right appears on top. If you switch it, what happens? Anyone remember what happens if you get them flipped? You'll get the correct answer, but you'll be off by a sign. So instead of getting a positive answer, you'll probably get a negative answer. All right. So the fundamental theorem of calculus, I'll put over here. The fundamental theorem of calculus said that when we are looking at this definite integral, that's what this was called, a definite integral, that the way we're going to do this is we're first going to find capital F of x. We're going to find its antiderivative. Then we're going to put the evaluation bar. And then what we're going to do is just plug in the b into this answer and subtract the a, like what we get when we plug a into this. Right? That's the fundamental theorem of calculus. It's on your reference sheets, but it's also it's on your formula sheets, but it's also something you can write on your reference sheets. All right, so the big thing for us right now to do is what? I mean, what's the big task ahead of us at this point? Finding the antiderivative, right? Like we actually need to figure out what this is, don't we? We need to figure out what that is. And it's not straightforward. It's not as easy as just like if that were just x squared or something like that where we could just use power rule. So what we have to do is go back to what we did last class. And yes, we're going to do this problem, all right? We're going to finish this problem. But instead of trying to work through it there, what I'm going to do is I'm going to say, hey, look, I want to know what is the antiderivative of this, right? Just what is the antiderivative, not the definite integral. This means, hey, go find the antiderivative, right? And when I look at that, I see, who sees what to do? I don't know, some of you may have done this already. Who sees what to do? Yeah? You have an idea? Don't tell me yet. So do you see x's to powers here? Do you see like x squared, x cubed? Do you see any of that? I mean, you can see that's x to the first power, right? But the problem is this is a quotient, right? And we don't have a way of dealing with quotients with any rules yet, right? There's no way to deal with this at this point. So what's the only other thing that you've learned? That we've learned? What's the only other method for finding an antiderivative that we have in our arsenal? Use sub. That's what we did last class. Use substitution, right? So that means, when you look at that, do you see something and its derivative? How many of you see something and its derivative? A couple of people? Okay, let me rewrite it. Now, how many of you see something in its derivative? Did that help at all, writing it that way? So, what's the something that you see? The natural log of x. What's the derivative of the natural log of x? 1 over x, see? So I'm seeing something in its derivative. So if you see that, right, substitution from last class says, all right, then what we're going to do is we're going to make a substitution. We're going to let u be equal to that something that we see, right? Let u be the natural log of x. And if I do that and then differentiate du dx equals 1 over x, taking the derivative on both sides with respect to x here, then what I can do is multiply both sides by dx. This was the common theme from last class, right? So du equals, now this is 1 over x dx, multiplying both sides by dx. I get to add a marker to my chain of markers here. Let's see. Oh, that's a good one. So now we play that game, right? We try and see if we can match things up. And I see here that I have exactly 1 over x dx. I have that exactly, don't I? And so that can be replaced with du. And I see that natural log of x I have right there, so I can replace that with u. So I'm basically rewriting the entire integral in terms of u instead of in terms of x. So what does this new integral become? Antiderivative of u du. And that's a much easier antiderivative to find because now you just have u to the first power, right? And this du, remember, is just keeping track of the variable. That's what it's doing. So what's the antiderivative of u? Antiderivative of u. What is it? What's the antiderivative of x? No, that's the derivative. Antiderivative. X squared, but then you need to kill that x squared out. So 1/2 in front, right? So this should be 1/2 u squared, and then plus c. Y'all okay with this power rule? At a bare minimum, you need to walk into Cal 2 and you need to be comfortable with this power rule, all right? Because it's just like, it's like me asking you what the derivative of x is, right? At this point, everyone would be like 1. In Cal 2, power rule backwards should be something pretty straightforward. So make sure you review that before you start Cal 2. All right, so that's x, that was u to the first power. All right, now this can't be my answer, right? Because my original problem was in terms of the variable x. And so I need to go back and replace this. What was u for us? Natural log, right? So we get 1/2 times the natural log of x squared plus c. That's our answer. Well, that's the antiderivative, right? We still haven't answered the problem yet, but that's our antiderivative. Can we check our answer real quick? Let's just check our answer. How do we check it? Take the derivative. Okay, if I ask you to take derivative of this, 1/2 comes for the ride. Okay, so imagine I'm taking derivative of that. The 1/2 will come for the ride. And then the 2 would come out, right? 2 comes out times the natural log of x to the first power, right? The 2 came out. And now the derivative of what was inside. What's the derivative of natural log of x? 1 over x, right? And so what happens here is these go away, and that's just natural log of x to the first power. That's just natural log of x times 1 over x, which is exactly this. Yes?
What about the du? Did you just,
So again, this just, when you write this, right, what this notation means is this capital Fx is the antiderivative of this, right? This right here, this differential, always confuses students. It's keeping track of the variable in the problem. So when I say, hey, go find the antiderivative of u, I'm telling you u is the variable here. That's just keeping track of the variable. That really plays a bigger role like in Cal 3, because you could be doing the antiderivative of u, and this could be dw or something, and then the variables aren't the same, and then that's a different answer. So this, just don't ask yourself what happens to this. Just focus your attention on that. Just like here, we were saying, what's the antiderivative of this, right? This is just telling us, yeah, x is your variable, right? All right, coming back over here, right? Coming back over here. Hold on a second. Spam. They got me, man. I don't know who did it, but they got me. Probably one of you, right? Did y'all share my number online? I had one of my students tell me I need to stop giving my cell phone number out. They said that you can get like a Google number now or something. Do y'all know anything about that? I need to look into that.
I do that whenever I sign up for anything, like stores and stuff.
I just tell them, no, you can't have my number. Oh, yeah, that's true. That's true. The reward, that's right. I do that at, what's it called? What's that sub place? Jersey Mike's, right? Get my points. Get a free sandwich every once in a while. All right, come on. What are we doing? Where are we? Yeah, so I had erased it, right? So let me go back here. Let me go back to the original problem. The original problem was the integral, right, from 1 to e of natural log x over x dx, right? That's the area under that curve. We needed to find the antiderivative of that, right? Which we just found is this, yes? I told you, though, when you do definite integrals, you can ignore the c because the c will cancel out when you do that step of subtraction. So I always just say, when you get to this point, just ignore it and put that in there. 1/2 natural log x squared evaluated from 1 to e. And now, again, last class, I told you what I like to do is to put two sets of parentheses. One of them is when I'm going to plug the e in, and the other one's 1. You have to do it in that order, right? It's always this in here first, and then subtract this in here. So I have 1/2 natural log of e squared, and then over here 1/2 natural log of 1 squared. And you actually do not need a calculator here if you remember some stuff about natural log and e from college algebra. When you do natural log and e together, they kill each other off and you just get 1. So that's just 1 squared, which is 1/2. And then also in college algebra, you learn that natural log of 1 is 0. So that makes this a 0. It all goes away. All right, so that's 0, and this is 1. So your final answer is just 1/2. Do y'all see where that comes from? So that's a good problem because it's actually, I'm kind of killing a few birds with one stone there, right? First of all, do you know what a definite integral is? Do you know how to actually do an area and turn it into the integral? And then within that actual first step of finding the antiderivative, you actually had to go do u substitution. Yes?
Do you want us to simplify the right side of the
Sim Up here? Oh no, you need to simplify that. I mean, it's a number. You should get. We're asking for the area, right? So you should try and take it to a number.
So in this case, it would be 1/2.
1/2 is the answer. Yep. Now, just keep in mind though, like let's say this had been like, natural log of 4, right? Natural log of 4, you'd need your calculator. You do natural log of 4 in your calculator. You'd square that answer and you'd multiply it times 1/2, and then that would be your answer, and it'd be a decimal. I made this problem on the test 1 to e because I knew that the numbers would work out nice. Was that a question?
Yeah, on number 20, so just to use the substitution, do we still have to go find, like...
Okay, good question. Let's do it, right? Is that all right? Okay, so number 20. So the question was, do we have to do the same thing on this problem? Well, is this asking us for the area? No, because this is called an indefinite integral. It's an indefinite integral. That means you're not given numbers. When you're given your numbers on the top and bottom of the integral sign, that's called a definite integral. That means it's going to represent an area and you should get a definite, like, numerical answer. When you're not given numbers, then all this wants you to do is find the antiderivative. That's it. Just find the antiderivative. We'll have a plus c, and that'll be our answer. We'll box it up. Okay? So, antiderivative of that. We could use u substitution. Do you see something in its derivative? Yeah. 5x, or x to the fifth plus 1? X to the fifth plus 1? So if you let that right there be u, what's the derivative of x to the fifth plus 1? What's the derivative of that? 5x to the fourth, right? Do you have a 5x to the fourth? No, what do you have? X to the fourth, but what did I tell you? It's okay to be off by a constant. You need the x to the fourth to be there, but being off by 5, that's okay. If you're off by a number, it's all right. So that's what we're going to use. Let's go for it. I also talked to you about, the lottery, right? You can't win if you don't play, right? So you can't get these problems if you don't try something, right? You got to do something. So u is x to the fifth plus 1. Why do I not use x to the fourth as my u? What's the derivative of x to the fourth? 4x cubed. Do you see an x cubed? No, right? Why don't I use the whole thing? What's your question?
So to find u, does the derivative of what you have of u have to equal either what's the denominator or the numerator?
Whatever you choose for u, its derivative has to appear somewhere here, and it needs to be, it could be off by a constant, but it needs to be somewhere that you can move it off to the side. In other words, like you need to be able to rewrite the problem in a way that that derivative thing is off here on its side, because this thing right here is going to somehow turn into a du something. I don't know yet what it's going to be, but somehow this is going to get turned into something with du, because the derivative of this is going to have an x to the fourth in it. Understand?
Yeah.
So if this x to the fourth was somewhere else, like let's say that x to the fourth was on the bottom. Let's just say. Like this. Look at that problem. If you try this u substitution, right, do you see its derivative? Yes, but no, you actually don't, because if I rewrite this, that's actually 1 over x to the fourth, isn't it? That's actually 1 over x to the fourth out here. That's not x to the fourth, it's 1 over x to the fourth. That's not the derivative of that. Do you see the subtle difference between these two? And I mean, at the most you could do here is write that as x to the negative 4, and that's definitely not the derivative of this, right? So what do you do in this case? Well, you don't. Not today. We don't do that today, right? We can't handle that yet. So the problems that I give you, I have to make sure they work, like that there is a u substitution that works. All right? These problems are very, very like custom, tailor-made to work for you, right? All right, so I'm doing this, yes? Next step, take derivative of this, right? And since this is now, we've done a few of these problems, just watch what I do first. Because in a Cal 2 class, we stop doing du dx because we know every single time we do that on this side, we're going to multiply both sides by dx. So what we start doing is just say, hey, take derivative of this, put it here, and then just slap a dx to the side, because it's always going to be there. And this side's du. Is that all right for me to do that? Now you're playing this game again. You're trying to see like what matches up. I mean, we can start here if you want. That right there is our u, right? So that's going to be replaced with u. Wonderful. Now, this right there, I don't quite have over here, right? Because I have that 5. So I want to get this by itself. So I need to get rid of that 5 over there. And I have a little equation here, so I can always get rid of this 5. I could divide both sides by 5, couldn't I? Or multiply by 1/5. I think that's the better way to look at it. Right? That's the same as dividing by 5, multiplying by 1/5. And now they match exactly, right? That matches with the purple there, so I can replace that entire purple piece with that. We okay? We're going to rewrite this integral now. All right, what does this become right here? 1 over u to the 4th power, right? 1 over u to the 4th power. 1 over u to the 4th power times, now what's the x to the 4th dx turn into? 1/5 du. Now that 1/5 is kind of it's kind of a pain to have it there. So we have this property of integrals that says that any constants can come out. Right? Constants can come out. How do you find the antiderivative of that? Because that's where we are, right? I mean, that's where we are. What can we do? Can you do this? Let me ask you this. Can you just say, oh, the antiderivative of that up there, the antiderivative of 1 is u, and then the antiderivative of the bottom is 1/5 u to the 5th. Am I allowed to do that? Do y'all understand what I did? Right? What's the derivative of u? 1, derivative of that is that. Can you do that? No, right? This is not allowed. There's no rules yet for division. There's only rules for like x to a power, right? Or u substitution. So the only hope I have for doing this is if I can somehow rewrite this as u to a power. Can you? That's the same as u to what power? -4 du. And now for this piece right here, remember, this is just keeping track of our variable. What's the antiderivative of u to the -4? We use the power rule, right? The power rule for antiderivatives. So I'm going to add 1 to that power and then put 1 over that number in front. Let me write it down. So I have the 1/5 that's in the very front. I'm actually taking the antiderivative now, right? I'm going to do it, so I'm no longer going to write the integral sign. I'm going to have u, I left a space in front on purpose, to what power? -3, right? Because you add 1 to the power. So take that, add 1, you get that. And then in front of that, you always have to put 1 over what? That power, whatever you had up here, 1 over this. Remember, we want that -3 to cancel out, right? That's why we have to put a 1 over -3 in front. And I'm forgetting one important thing here. Plus c. See, it's an indefinite integral. We'll always have plus c. And then this will be, let's see. Let me write it this way. -1 over 15, right? Negative, that's just multiplying straight across here, putting the negative in front. That's those two together. And then u, what was u for us? X to the 5th plus 1, raised to what power? -3, right? Plus c. This is our antiderivative. Let me check my answer. I'm going to check it to see if it's right. Shouldn't take me too long. I'm going to take derivative of this. If I differentiate this if I differentiate that, the negative 1/15 comes for the ride, right? Okay, take derivative of this to the negative 3, so negative 3 comes out. Then I have all of this to what power? I subtract 1, right? So negative 4 times chain rule, now the derivative of what's inside, 5x to the 4th. Do y'all see what happens? You got two negatives become positive. 5 and 3 is 15. They'll cancel with that 15 there. And what you'll be left with is this to the negative 4 times x to the 4th, which was the original problem, wasn't it? Isn't that the original problem? Because you would drop that, you leave the x to the 4th on top, and you drop the x plus 5 down and raise it to the 4th power. And that was what the original integral was, right? So it works. Okay, good. What else? How are we doing time-wise? Well, we only have about 30 minutes left. Number what? 17. How are y'all feeling about this test on Thursday? Yeah? Feeling all right? See some positive nods? So there's a chance, I'm not sure how big this chance is yet, but there's a chance that I might be on campus on Sunday to do a 3-hour study session with my Cal 3 class. And so I think there's a lot of them that are going to get together. But if I do, I'm going to open it up to my other classes as well. I'll let you all know. I don't know for sure yet. I'm going to look at my schedule and see. But it looks like probably Sunday, I don't know, evening, somewhere, 6 o'clock, 7 o'clock, somewhere around there. It might be kind of late. We will see, all right? But I'll let y'all know. Number 17. So you have, I give you that f double prime of x equals 1 minus 6x plus 48x squared. I give you that. I tell you that f of 0 is 1. And I tell you that f prime of 0 is 2. And I tell you to find f of x.